All right, hello and welcome back. And this is part two of our, episode. I mean, we're on episode 24, but this is part two of working on adding variables and assignment statements to our programming language. And it is still Halloween for one more hour, so I'm still dressed as my chair. There you go. And you say, Corey, you've made that joke now for 3 videos now. Well, I've recorded all 3 videos tonight, and I'm not changing my shirt in between them. So, let's see, what are we doing? My name is Corey, if you haven't figured that out, and we are building a custom programming language. It's designed to be, or it's intended to be used as a templating language, right? So that you could write something out as a template and it would interpret that. So it has variables and it will have functions and everything like that. Yes, so we are writing our own language. Think of it as a weird mixture of PHP, Python, C++, different syntaxes that I like and features that I like, but stripped down. In how stripped down? Well, we want to be able to protect the user against themselves. And I talked about that in my very first video, but this is video number 24, which means it has been a while since I talked about it. So I'm just going to say the whole goal is you want to save the user from themselves. So they shouldn't be able to get into infinite loops. They shouldn't be able to access parts of the computer that you don't want them to. They shouldn't be able to open files. They shouldn't be able to do network requests unless, like I said, you specifically give them that ability through the language. And since we're writing our own language, designing our own language, if we don't write it, it doesn't exist. And that is both the terrifying and the exciting part. If we don't write in optimizations, they don't exist. If we don't write in a feature, they don't exist. If we don't give it a library, it doesn't exist. And so, yeah, why not? My goal in this is 100% live coding. That is, you're seeing me make my mistakes. You're seeing me right now. I worked all day, start at 8 a.m. and right now it's 11 p.m. at night, and this is my 3rd video I'm recording. So I'm sorry if the brain fog is going to set in every once in a while, but quite frankly, I have fun with this and I enjoy it. And so, yeah, we're going to see how this is going. We pick up exactly where we left off in the previous one. That is, if I say git log, you see the last commit that I made was tagging the end of episode 23, and we're going to pick up from there. What did we do? So 2 episodes ago, we added statements to our programming language, and end with a semicolon, and you can start another statement, and that those are stored as a code block, even though we haven't written the ability to have an opening closing brace and then a lot of code and then a closing curly brace, but that's actually not that difficult. We just haven't done it yet. We don't need that yet. What we want is the ability to have variables. That's what we're doing now. So we are going to need an AST type. And I should clear this, and it's going to be an AST type that is an identifier. What do I mean by identifier? Well, think about a variable name is an identifier. So is a function name. So is, if I say A dot B, the A is an identifier. The dot is, we haven't written that into our language yet, but I'm just saying it's an access token of some sort off of A, and then B is an identifier. So we need something to represent that that piece of information. So let's do that. We can start off with I like to copy a lot, so let's copy the source of AST node integer, and it will be called source AST node identifier.cpp. And we're going to do the same thing for our include AST node integer is now we're copying it to AST node identifier.hpp. There we go. I'm also going to edit the make file and go ahead and add that in. So this is our AST node. Whoops. Float. This is going. I'm just trying to. ASP node identifier. Okay. AST node integer. Let's copy this, and we need to do it this way. And hey, it's the same day. I haven't looked up how to do relative ranges yet. I'm sorry. So 71 and 72, we're going to substitute integer for identifier. There. We've got it. Those two lines. I'm going to go ahead and start with the compiling over here. It's going to complain because I've just copied the files. They're not any different. So we're going to open our include AST node identifier and our source AST node identifier. Okay, and now %s all caps integer will now become identifier identifier. You say, Corey, what are you stopping for? I'm thinking. Yes, I'm thinking. Oh well. Okay, we can go there, and we'll do the same thing. %s integer title case to identifier title case. And now identifiers are represented by pound include string there by a string type. There. How about this? Identifier names are represented by a string. How about by a string? Okay, so this is an AST node that represents a we can say an identifier. Okay, that's fine. Constructor, this is going to be name, and it is going to be the name of the identifier, and standard string name. I should actually do this as const standard string ampersand name. All right, and the dump, the compile, make copy. That's all fine. This will be the name of the identifier. Okay, standard string name. That's good. Now we need to do this again. And now fix all the stuff that we just broke. So our name, there we go. It's going to be an identifier and then, oh, yeah, plus this arrow name. The compile, this one is going to be a little more difficult. We're going to have to come back to this. Because we don't have what we need yet. And make a copy. We need to give it name. Even though I'm not convinced that we need make copy anymore. And oh, it doesn't like that we're not using program. Well, I know. We will get rid of that later because we will be using it. But for right now, this should work. Should compile and we've got no problems. Good. Okay. We also need an assignment operator. I'm trying to decide if I want this. I don't think I want it to be the binary. I think I want it as just a separate assign. I'm trying to decide. Say, Corey, why didn't you think of this earlier? I don't know, I'm tired. That's why I didn't think of it earlier. The binary or the assignment operator has a fundamentally different operation than the binary. The binary loads the left-hand side, it executes the left-hand side, it executes the right-hand side, and then it does some sort of operation. That is not what an assignment does. An assignment only executes the right-hand side, and it uses the identifier, or whatever it needs to get down to, on the right-hand side to then assign that value somewhere represented by that identifier. The identifier is bound to some location, so to speak. And so for that purpose, I think we're going to make an assignment, an AST node assignment. Okay? Yeah. So our makefile, we need an AST node assignment. So just assign, just like add, subtract, assign. Okay, and AST node binary. There we go. And we're going to now 51, 52 substitute binary for assign. There we go. And now we need to copy our source for AST node. I'm going to use binary in this case because I do want to start off with that. AST node binary to source AST node assign.cpp, and also our include AST node binary.hpp to our include AST node binary, not binary, assign. Don't let me make mistakes like that. Come on. And now it's going to complain because they're all the same. That's fine. We're going to edit our include AST node assign and our source AST node assign. So why do I read all this out as I go? Because that's what I'm thinking in my head anyway. So I've got to do it. %s, and we are going to say yeah. Binary is becoming assign globally. %s and binary is coming assign title case globally. Okay, now let's do this. Do we need our enum? Oh, I don't have a description on that. I should, but oh well. No, we do not for the moment. Constructor, we don't need the op, and so we're going to remove the op. We don't need, we do need left-hand side, right-hand side location. That's fine. Compile, yes, 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 yes. We don't need to store the op. Okay, simple enough. Let's do the same things. Go to the beginning. Now let's see. We don't have the operation there, which means we don't need it in the initialization list. In the dump, don't need any of the description. We just need assign. Yes. It's like, how did it know it was assigned? Because it said binary before. So assign, and then our left-hand and right-hand side. That's fine. The compile, this is for the assign. We do have to compile the right-hand side, but we don't need any of this. I'm just keeping the bytecode because that way I don't have to look it up what that looks like. And for make a copy, we don't need to give it the op. Okay. All of our tests are passing still. That's always a good thing. So we've got our AST node for an identifier and for an assignment. That's what we need, right? Because we want to have variables, they have names, and we want to have assignments. So now let's go to Flex and Bison, start fleshing this out, and figure out what we need. We haven't added our opcodes. We'll get there. Let's go to Flex. So first of all, we have to decide, what do we think that an identifier will look like? And the reason I bring that up is because, did my video finish uploading? I think it did. Okay. An identifier, I had my regex cheat sheet over here somewhere. Yeah. An identifier can have, well, in most programming languages, it can have A through Z, right? Upper or lowercase. And it can have a number at the end, or excuse me, anywhere but the beginning. So you can't have an identifier that starts with a 3, but you could have, foo3. You could start with you could have an underscore anywhere in there, right? But usually that's the only characters. You can't have a dash. Why? Because it looks like a minus. So yeah, let's write that. So we've got all of this stuff. We've got our floats. Let's put it right here. What would it be? First of all, we want it to be A to Z, anything, or a capital A to capital Z, or an underscore. It needs to be at least one. So that grouping will give us that. And then another grouping that is A to Z, or capital A to Z, or 0-9. So here's the numbers, 0 to 9, or an underscore. And we're going to have 0 or more of that. So one character is required, and it just can't be a number. It can be any letter or an underscore. Yeah, that works. I like that. Okay, so what do we need to do? We need to return a Tang parser. We haven't said this yet, but we're going to call this an identifier. Yeah, and what do we need? We need to give it... is it just YY text, I think? Yeah. YY text, in case you're wondering, is we used it up here for the numbers, right? YY text is the text that got matched. So we're giving it YY text. And then location. Okay. It's going to complain because it said I don't know what an identifier is, but we can go into Bison and add that. So it's going to be a token, and we'll put it up here with these other tokens that we're kind of just putting in there. So, no, I didn't mean to do that. I just hit the wrong button. We're good now. A token, and this is going to be a string. Do I need to say standard string? Maybe. These don't need spaces. Don't know why I have them there. Okay. And identifier. Oh, but what's its actual name? Identifier. There we go. All right. Now. Oh. My caps lock was on. Okay. Assuming we don't have any compile errors, which doesn't look like we do, now we need to go in and say, where can an identifier appear, or what should this look like? Oh, by the way, why is it doing that? Because I need to make clean. I know it. Make clean. And again, it's just somewhere it didn't rebuild everything that it should have. Let's go down to our grammar. So we know that a program can be a single expression, or it can be statements, or nothing. So an expression is then where we need to have our something is equal to something else. Okay, so something else is broken. We'll get there. Here is integer, float, boolean. I think minus, not, less than, greater than. double equal, not equal to, parentheses. Do we want to put it there? I'm going to put it at the top. Say, Corey, all that to figure that out. Yes. So this is going to be just a single equal sign. Do we recognize a single equal sign? I don't think we do. That is not where I wanted to look. Yeah, we don't have it. Okay. Let's add it in. Where do I want to put it? Not equal. I put it above the plus, so let's down below. So I'm going to put it here, there. Token, and we will say equal. And by the way, we're going to have to tell our program that what an equal is. Tell Flex that what an equal is, because we didn't add, and we need to add the precedence for it. And getting there. C++. Precedence. Yeah, operator precedence. And we can see that, you know, again, I think that these are, yeah, the not is right here, and it's like in reverse order. So what's at the bottom of this list will be at the top of this one, and the equal is here, and it is right to left. You want to do what's on the right hand side first. So we will put %right equals, and still going to complain because we haven't told Flex what an equal sign is. So let's do that. There we go. Do I need to escape the equal sign is what I'm looking for. No, I don't. I don't. Okay, so an equal sign and equal. See if this is okay. It gave me an error there, but I don't know if you saw it. Rule cannot be matched, line 178. And I think that's as. What? I'm looking to see if I missed something. Oh. I want to double check something. What did I call the double equal? I said equal compare. This should probably not be called equal. It should probably be called assign. And that is, yeah, so, I mean, that's fine there. But that doesn't fix the problem with flex. And so the reason I'm stopping it is because I want to, I just wanted it to do that so that I can make test and why didn't it regenerate the flex? Oh, hey, there it is. Shouldn't be equal anyway. It should be assign. Like I just changed it and wasn't paying attention. Assign. There we go. Now, I know it was going on and on, but what I care about is grabbing this line right here and pasting it back in because I just want to run that. And it's saying line 178, the rule cannot be reached. And 178 is, it says as. And that doesn't make any sense to me because it's in the middle of a rule. It's not a rule. Live coding, people. That's what you get. So what I'm going to take out the equal for the moment. And just change the line. That doesn't make sense. That doesn't make sense at all. So I probably have something wrong here. Check my reference. It looks correct. So let's do this. D2 enter. That worked. Okay. Okay. Why? So shouldn't I be telling you that? Order matters, I think. Pretty sure. Yep, that's why order matters. It needs to know that it could get to as first because AS matches this pattern. Yeah, that's why. That's what was saying. And by the way, I bet if I moved, if I move the equal that I just wrote, I'm just going to delete it, and I'm going to put it down beneath the double equal. This is just temporarily. and ran it, it's going to give me the same problem. No, it didn't. Okay, don't know why. I give up. Oh well, I'm putting it back up top. Either way, make test watch. So yeah, order matters, and I had forgotten that. That is one of those little bitty tidbits of things I forgot. All of our tests are passing now. Were they failing before? Because it couldn't get to the as, and it was only recognizing the as an identifier, which of course it didn't know what to do with. All right, so now, what do we do with this? Well, let's look at a test. That is the wrong window. There we go. Down at the very bottom. And we'll just yank these. And these are going to be assign identifier. Why? Because there's different types of assignments. We'll find out later. If you are doing an index into an array, that's a different type of assignment. Or if you're saying a dot b is equal to whatever, that's a different type of assignment. So this is just a standard identifier-based assignment. And what we're going to do here is we're going to say a is equal to 1, and then the value of a. That's the first one. I didn't want to start that, but anyway. What I want to do is I want to do cout p1 dot dump bytecode. I remember that from the last one. And it should be nothing. And yeah, there is nothing there because we haven't said what do we do with this. First of all, we never finished with Bison. So let's go back to Bison. What number is this? Bison is 4. All right. We're just going down to this is an expression. An expression equals. So, okay, we did do that part. And we're just saying, so why are we doing expression equals expression? The reason is because there's a lot of ways you could get to this. Maybe you call a function that returns a value, and that value then you can access with a dot specifier or whatever. Maybe there's something really complicated to be able to do this assignment. Or a string. Or, no wait, better or easier to think about, an array. You want the ith element of an array. So you've got your array, names, sub, square bracket, I. Well, that's an expression that you're trying to get to, and you want to assign a value to that. So on the left and right-hand side, both have to be expressions. And yeah, that's why we're doing it this way. Now, we need to go to our compile step. So the compile step, that's going to be our node assign. Yes. So that's 2. And in the compile step, we are calling the right-hand side compile. And why isn't it doing that? I thought it should. we should at least, if we go to our test, which is 5, and then come back to 2. Okay. Our test at least does a is equal to 1. It should at least push a 1 integer onto the stack, even though it doesn't know what to do with the equal sign yet or the a. And it should pop that. We should be seeing that in the bytecode, but we're not. Why? So let's do this. Cout p1.get ast dump. I think it's that. Oh, segmentation fault. Did we get a segmentation fault earlier? No, we did not. So if I'm getting a segmentation fault when executing this, that means that the get result doesn't exist. The AST doesn't exist, which is why it's not giving me anything when I say dump the bytecode. Okay, so why is the AST? Why is it not compiling? Oh, I never told it how to compile an identifier. Okay. I think that's what the problem is. Let's go back to Bison. And yeah, I've got null, integer, float, boolean, and I don't have identifier. I don't think I've got it at the bottom either. No, I don't. So we need to tell it what to do when it gets an identifier. Let's put it, well, an identifier, and we're going to make sure it AST identifier. And an identifier, it's coming in as a string, right? This is a string, and we are passing that as a string, $1, to this, sorry, on the wrong line, to this AST node identifier. Yeah. Hey, I didn't know I could do that. I hit VW and it highlighted the entire word. That's cool. In fact, now I want to know if I do it here, if it's, no, that's FW. VW does it to the end. So if it was because I was at the beginning, but if I do VIW, yeah, that's the entire word. It looks like it's not getting the last letter, but it does include the last letter. It's where the cursor is. Anyway, okay, that's interesting. Learned something new about Vim. So now, when I save this, oh, it probably doesn't know about the identifier. It's going to say, what is that type? Yeah, it's AST node identifier. Oh, the includes are going to kill me. All right. Now, it's still saying insufficient stack depth, so that's fine. I know that. I don't care. What I care about is we've got a block that's a binary. Whoa, it called a binary add. That's not right. Because the code is a is equal to 1. So integer 1, and now it's calling add. So it's reading it as a binary add instead of an assign? Is this just me being stupid? That's a distinct possibility. Yeah, it's me being stupid. See, I said node binary, and it should be a node assign, and I don't need this. Well, let's see if we get any better. Wait. It doesn't know about AST node assign. It's like I need to tell it about that as well. I hope that's what I named it. Okay. Still, I don't care about the stack is empty. I know we haven't finished getting all this ready yet. But what I do care about is it's a block that has an assignment. The left-hand side is an identifier of A, and the right-hand side is an integer 1. So it should be A is equal to 1. We haven't written that yet, but that's what it's showing up as. And then after the assignment, just the identifier A. Okay, that's fine. Now, what's the opcode look like? Well, integer 1, so that worked. It did do the right-hand side, and then I didn't write anything else for it to do, and so it pops it because that's the end of that assignment statement. I got to a semicolon, so it popped the result, and now it doesn't know what to do with identifier, so it ends. Stack is empty, gives us the error. So what we've got to do is two things. Now, we have to decide where we're going to put these variables. And if you've been doing programming any length of time, you know there's the stack versus the heap in any program. And the stack is where all of your stuff is executed. Your normal memory allocation, that is your immediate memory allocation. And then the heap is where all the dynamic memory allocation happens. Very high level description here. We are not really doing that. There is kind of that idea, but for right now, let's just say that we want to reserve a place on our stack for that variable A. Okay, that's what we want to do. We want to reserve a place on the stack for that variable A. And in order to do that, we have to know that the variable A exists. Okay? The variable A exists. How do we do that? We need to ask the AST nodes, hey, does this do you have any variables? So we are going into the AST node, the main one, so we can add a method. And so for this, we're going to edit the include for the AST node, and we're going to have a new public function that is going to, we need to pound include set here. Pound include set. No. We don't need that. We will use a set for this, but we don't need it yet. And this is going to be compile a list of all variables in the scope. And what am I forgetting? I forgot to add at param is going to be program the Tang program that is being compiled. Why? Because we have to have somewhere to store these variables that we find. If we identify, hey, there's an A, I have to tell someone about it. I'm going to do that in the program object. Okay. It's not going to return anything. So this is going to be, it is virtual. It is a void. Compile. Identifiers. No, and it's not a const. Definitely not. Program ampersand program. I'm const, but it's going to modify program. And now we need to put this in the source program .cpp. No, not program. Sorry. AST_node.cpp. So we're going to have I was going to say, this is actually not going to do anything. By default, hit the wrong. Maybe unused. There we go. So it won't complain. And now we're going to in the program, let's go there. Let's do our source, no, edit, include program, okay. And because, we're going to do this as public because the things editing it need to be able to access it. And what is it going to be? It is going to be, do I have a vector? Included. I do have vectors. Probably going to need a map. Yeah, I'm going to need a map. Okay. What is this? Well, we're going to have the not private. It's going to be public. What is this? This is going to be the sorry, brain's shut off for just a moment. This is going to be a mapping stack of mappings of identifiers to their stack locations. Okay, and this is going to be a vector of maps. And what are the types? The map is going to be a string, which is the name, to a location, a position. Yeah. And we're going to call this the identifier stack. Do I want to call it that? Why are we saying it's a stack? Because think about this. If we're compiling and there's a variable declaration, and it may have variables inside of it that we don't want to affect the variables outside. And so yes, I think that is, yeah. Using a stack structure will allow us to do that. And so when we begin the compilation program, is that right? Yes, it is. So where is that? That's going to be edit, not include source, program.cpp, and we're calling this identifier stack. That's fine. When we compile, that's all the roll of 5 stuff. We're saying this AST compile. First, we need to this AST and say compile identifiers this. Okay, so we're telling the AST nodes to gather up all of your identifiers and put them in wherever I am, but they're going to put it in the topmost stack. And so in fact we need to do that. We need to this identifier stack, is that what I called it? Identifier stack, yes, okay. Identifier stack dot push back, and what is this? This is a map of string comma size t. There. Will that compile? I was going to say it should, but sometimes it doesn't like these L params and R params. Okay, or L names and R names. Okay, so we are pre-populating the identifier stack. That is, we're pushing an empty list so that when the identifiers are compiling, they can add to that. Now, in my example of a function, what's going to happen is if there's a function there, it's not going to add those in. It's just going to skip over it. And then later, when we need to compile the function, it's going to push a new empty map onto this stack, and then it will go through all the function stuff. And when it's done with its compilation stuff, it'll pop that off and we'll have the original mappings. Yes. Okay. Say, Corey, that's a lot. Yeah. It's very abstract. And, but in fact, normally I would, okay, so I'm going to we will prepare the identifier mapping stack with an empty map. Okay, and then this one will say gather all of the identifiers identifiers in the current scope into the map, into the current map. Sure. And then last is going to be compile the program. There we go. So let's do this compile identifiers. Generally speaking, most of them they don't need to do anything because the integer isn't an identifier or anything. So let's the compile identifiers. Where would it be used? Where would it be recognized? And the answer to that is first of all, let's go into the AST node identifier. We'll do that one first. AST node, yeah. Edit, and that's going to be first the include AST node identifier. There we go. And AST node, which one is that? 6. So 6 and then 10. There we go. And we're just going to add this here. Which will void, and we need to add the fact that this is an override. That's just good hygiene for your own code. And now it's going to say it's missing this one, and I'm going to say, oh no, it is. Imagine that. So 7, there we go. And now we need to edit the source for AST node identifier.cpp, and I think it would be there. And now it's no longer going to be unused. And what do we need to do? We need to say, okay, how do we know if something is in a map? I think you do a count of it. So, not const, auto ampersand identifiers is equal to program dot identifier stack dot back. So this gets the top of the stack, and I want to know. So I'm going to say if identifiers.count of this name is equal to 0. That means it doesn't exist. I need to add it. Identifiers is it dot size, I think. Never hurts to look it up. Just want to make sure. C++ map. Pretty sure it's size. The container size. Yep. That's fine. So what it is the first one's going to go, if the size is 0, then it's going to get... Is that going to be right? I think so. Identifiers.size. Okay. I need a variable name, don't I? You know what? I don't even have to do it this way. There we go. So I'm just adding my name to identifiers if it doesn't exist yet. Simple enough. Now, stnode identifier. There we go. It still hasn't solved our issue because we haven't gotten into the identifiers yet, because it has to go through the block and an assign and the binary. All three of those need this line. So we're going to edit the include for the AST node block, or wait, assign will work. That's fine. There. Assign. Edit for the include AST node binary. There we go. And for the AST node block. Okay. And now I need to edit their CPP files. And where are the node identifier.cpp? Yeah. Just because I'm going to copy that. And so now we're editing the source for AST node assign. Compile identifiers, and we just need to do just pass it through and do the same thing for right hand side. Okay. Let's edit the source for AST node binary. And the last one is edit the source for AST node block. Block is slightly different. So what we need to do is we need to go through all of its statements. Yay, this time we can use the for auto, I'll use X, I don't care. This arrow statements. And now we'll just do there we go. Compile identifiers. So X, go through the statements for each X, compile its identifiers, and pass it program. And so, oh, yeah. This is a block. I still haven't done anything with this, right? We're just getting it so that we're collecting all of the names of all of the variables. But we're actually really close now, because what's happened is we know that, okay, so how do I want to say this? By calling this on, let's go back to the test. Test, where is that? 5. Okay. When I say a is equal to 1, first of all, compile it. It's going to say, okay, I'm compiling a program. Give me all of the variable names. It goes to the block. The block says I'm going to go through each statement. The first statement is a is equal to 1. It's actually the binary operator, right? Or excuse me, the assignment operator. A is equal to 1. And then the assignment. And the assignment says, okay, left-hand side, give me all of yours. Right-hand side, give me all of yours. Well, the right-hand side is just a number. And so that's the default one where that doesn't do anything. So it doesn't go anywhere. But the left-hand side is an identifier. And the identifier says, hey, is my name in there? If not, put me in. So now what we can do is, once we've done that, we can reserve the space. So let's go back to the compile. When we call program, AST compile, is that where we would do it? Whoops. So I want to look at the program compile. That's in buffer 9. So we prepare the places, right? We gather all the identifiers. Now we are going to reserve spaces on the stack for each variable. Okay? And so we do this. Sorry, I know what I'm trying to do. I need to know that bytecode. Oh wait, that was it. I thought it was. Nope, I'm wrong. Oh yeah, add bytecode. Hey, I gotta tell you, it's getting late. Dot push back, and now it's going to be what, a u int 64t of opcode null. So for each one of these, though, so how we do it is we say for x. We should do auto. I don't want it to copy it at all. This, what did I call it? Identifier stack dot back. Oh yeah, the name is up on line 87. I'm just going through it. The point is, I don't care what type it's supposed to be. It's being initialized as a null. And I may have to say maybe unused so that it doesn't complain. Oh, opcode. It's not. I hope that's what it's called. Oh, it's not null, it's null val. There we go. Null val. We still haven't compiled the other, but okay, look. It's reserved that spot for A. So we know that we were able to identify that there was an A there. It's getting a null val. Now, what do we need to do? In the assign, we need to be able to push that value into the memory location. And we need to be able to we need to be able to pull it out. And so for that, we need to, give me a sec, our include opcode. Yes. Now we've got this pop and we've got null val. We're going to add something here and I'm going to call it peak. And it's going to pop a stack number from FP push. So it's gonna, yeah, push val at location. That's fine. Okay. And the other one is going to be called poke. If you don't know about these, just Google it, peek and poke. I mean, this goes back to the basic days. So this is going to pop a stack number from the FP. And it's going to pop a val store at location. Yeah. So the idea, peak, I want to say, give me memory location 0. Whatever's there, it initialized to null, and it's going to pull it out. However, if I say poke, then it should, I should be able to say poke it in memory location 0. I'm saying memory location, I mean stack position. Poke it into stack position 0. And whatever is on the top of the stack, it's going to put it there. Okay, so now all that we need to do is write 2 more things. So we've got this peek and poke, and we just need to add these to the compile at the right place. So where? First of all, let's do the assignment. No. I want to do the identifier, the compile for the identifier. And so that is going to be in the AST node identifier.cpp. That is buffer 11. And this is our compile. And we're going to have an auto ampersand did I call it identifier? Is equal to program dot I can even do const just to be sure. Program identifier stack dot, whoops, dot back. Okay, and now, no, it's probably going to complain if I try to do const. Nope, didn't mean to do that. That's fine. If identifier.count this name. So that means if it does exist, then program.add bytecode opcode. What am I doing? I'm peeking. And program.add bytecode. Where am I peeking? As a cast as a uint 64t identifier this name. And I'm going to need to cast this also as a uint 64t. I think it's a uint 64t. It'll tell me if I'm wrong. Say, Corey, you really playing this fast and loose? Yes, I'm tired. In fact, I should... Sorry about that. Double check. 122. Okay. Else. I don't want it to fail, but we'll do program.add bytecode, and what would we want it to do? uint 64t opcode load a null if it doesn't know what to do with it. Now, again, just pardon me for a moment. I'm just making sure it's right because, like I said, I'm tired and I don't want to dig myself into too deep of a hole. Let me just hit save and see if it gives me a compile error. But, and I can remove this maybe unused. Why is it doing that? Because I didn't tell the program what to do with the peek and poke. So, okay, we'll do that in just a moment. Okay, so that's the AST node identifier. Now we need to do the AST node assign. Believe it or not, we are almost done. We have to add the compilation instructions for the assign and then just tell the program how to respond to peek and poke. So AST node assign. Did I close that? Yes, I did. Include AST node assign. No, not include source. There we go. And now it's compile. So the right-hand side compiles, and now we need to do something with that result. And the answer is if the type ID of the right-hand side is equal to the type ID of computed not a computed expression, AST node identifier. If that's the case, auto ampersand RHS con is equal to a static cast to an AST node identifier ampersand of this RHS. Okay, so I'm saying if it's an AST node identifier, do the cast so I can get to the information in it, specifically its name. And now I need to, it should be in program, right? So I'll say again, auto ampersand identifiers is equal to program.identifier stack.back. Okay. And now if identifier dot count of this, no, not this, of the right, I'm saying right hand side, those should be left hand side. Left hand side, and this should be left hand side. Of the left hand side, convert arrow name of its name. That should, hopefully that's not private. If it is, I'll change it from public to private to public. So if it's there, then I can add the bytecode of the poke and where. Sorry, I know I'm stopping. I'm just thinking it's identifier arrow LHS con arrow name. Okay, now what if that's not the case? The question is what is our peak? Okay, so peak will put something on the stack. Poke will put something into memory. Is it going to pop it off the stack? If it does pop it off the stack, which should normally be the case, yes, we need to put something back on the stack. You say, why would we need to do that? Well, because remember, you should, every statement has to have, every expression, and this is just an expression, must leave something on the stack. So, yeah, poke is going to leave I said it was going to pop, but we're going to leave it on the stack. Okay. So poke is going to pop it off the stack, And that. Now, what if it's not there? I still need to... Wait, did I say it's going to pop it off the stack? No, it's going to leave it on the stack. Leave it on the stack. So if I don't have the identifier count, nothing's going to happen to that value. I don't have anywhere to store it, but it's still going to leave it on the stack. Yeah. Okay, and now we're going to say if the LHS is an identifier, then I don't like doing comments like this. It should be like a statement, like a command. Store the value if it is sorry, if the LHS is an identifier. There we go. I like that better. There, that's better. And then this is going to be just compile the RHS leaving the value on the stack. And for poke, yeah, we're gonna need to. I'm gonna change the value. I mean the definition. Include opcode poke. It says pop copy, so it doesn't pop. Oh no. That it does pop that. It's copy eval. It doesn't pop a stack number. It is this the first one that has yeah. So copy eval, store at location, store at stack number. There. So the argument, and this is also not, this is a stack number from FP, and this is going to be push val from stack number. Sure, that kind of works. And now let's tell the program how to do this. So this is going to be edit source program dump bytecode. What order did I just do that? Peek and then poke. Pop, peek, poke. I'm amused because I'm tired. Pop, peek, poke. Peek. Caps lock is killing me. Pop, peek. And now poke. Oh. You may not be laughing watching this, but oh well. Source program. Oh, edit. Source program execute pop, peek, and poke. Remember. Pop, peek, and poke. So okay. Now, so what's the peek going to do? It's going to say size t position is equal to stack of fp plus pc plus 1. There we go. So the program counter plus 1. And now we're not popping. We're going to say stack dot push. Oh wait, now that we know where we're looking, now we need to do a we need execute program check. I knew I had one somewhere. So first execute program check of 1. Now that we have a position, we need to stack check position. Yeah. And now we're going to say stack.push back. And what are we pushing back? Stack of fp plus position. There we go. PC plus equals 2 because we went forward by 2. So the peek says, give me the position. Okay, there it is. I need to verify that I have that many things on the stack. And you'll remember that stack checks from the FP. So if I say FP 0, it should be plus 1. Position plus 1. Pretty sure. We'll find out soon enough. You know, we can look. We're on line 59. Just scroll up. Stack check is FP plus X. And so position 0 will be position 0. And we want to know if the stack size is less than that. But if we're looking for position 0, stack size is going to be 1. Okay, so it doesn't have to be plus 1. Nope, we're good. Okay, I wrote it the right way to begin with. Stack check a position. And now we're just going to push onto the stack whatever was at that position. Okay. Now for the poke. This is going to start off the same way. So we're getting the position. We're making sure that it exists. I am going to do a +1 because we're also about to pop something off the stack. Yes. And, oh wait, did we decide that the poke does not remove it? That's right. Poke does not remove it, so we don't need to do that. All that we need to do is we need to say that the stack at fp plus position is equal to stack back. Yeah. So on the source AST node assign, we don't have, whoops, wrong window. Wait, yeah. Pound include AST node identifier. These are no longer pointers. That is, there we go. And now is it going to complain about us? It's private within the context. No, so we're going to make that public because it, yeah, we should, other things should have access to its name. I mean, we could do a get name and everything, but not doing that right now. So let's edit the include AST node identifier. It's going to recompile everything. Oh, it's not liking this, but that's okay. Let's go back to the program execute .cpp. That's buffer 18. We've done a lot of editing today on line 57. I normally honestly don't like autos, but not too worried about it. Oh, okay. Yeah. Yeah. That's I'm being stupid. Position is not stack of FP. It is this bytecode. Yeah, you're probably wondering, Corey, what are you doing? Hey, I told you I'm tired. Segmentation fault. Of course. So, when it's a segmentation fault, it usually means that you are accessing a pointer in a way that you're not expecting. And where do we use pointers in this? Are we using pointers? The only place is if the AST is not being populated, because where's test? Buffer 5. Okay, still segmentation fault, but also just in case. Still getting a segmentation fault. So, not sure where it would be, but I'm horrible at GDB, by the way. Apps, test, run. So it is in the assign. The backtrace is going to be messy. Compile. AST no block. $33. Guess I could move my head so I'm slightly out of the way. I don't know. So, okay, if we test the way through, internal, there we go, test suite run, test run. This one, it is definitely compiling. A is equal to 1, and then A. And then the program code is that compile on line 99, which takes us to AST node block compile. Did I open the wrong one? No. AST node block compile. And then AST node assign compile 37. AST node compile. Do I have that one open? No, I don't. That is source AST node. I said compile, but I meant AST node assign .cpp at line 37. Ah, looky there. Right there. That should be an L. And so what I was looking at, and I'm exhausted right now, so I'm surprised I caught it, but the last place I recognized, there we go, it was saying here, because after that it gets into the standard template library stuff, and that means I'm calling it wrong. I'm doing something wrong. And the last thing I could see was AST node assign.cpp line 37. So that goes over here, 35, 36, 37, and I'm doing identifier.count. So I looked at what did I do with identifier. It's just the program identifier stack back, and I remembered having set that explicitly, so I know it has a value. And then LHS converted .name. So I was like, well, did I do that wrong? So read that line. It's LHS, and there was an R there. Okay. So let's exit and see if we do any better this time around. Hello? Oh, hey, we've got some stuff. So, let's get back to the test. I think that's buffer 5. It is. I've done it enough. So we said expect equal to, but it says that it is a 1, and looky there, that is what the value should be. And we know that they get initialized to a null. So let's look at this. We've got a is equal to 1 and then just an a. So we reserve the spot of a. We set the expression gives us an of 1 there, integer 1, and now we poke it. Oh, I didn't say where to poke it though, did I? Oh, yeah. So poke and the peek. This will make more sense. Let's go back to the program dump, and so pop just does that, but peek, you'll notice sorry. So for both of these, don't program check. Does that say one more? The program counter plus however many. So yeah, okay. And this should be PC plus equals 2 instead of 1. Whoops. There we go. And this byte code of PC plus 1. There we go. Same thing here. Okay, so I wasn't dumping them correctly, but this should fix it. Okay, let's go back to our test. There we go. Okay, so here we have our null value, integer 1 that we're pushing. We're poking it into memory address 0, and then that gets popped because that is the end of the command. Now we're peeking 0, which is pulling it back off, and now that's at the top. Yeah, that's it. That's it. Now, the question is, in my program, execute, at the end, yep, I clear my stack, which that's the cleanup. Okay. This is working. And the bytecode will dump now, by the way. So yeah, we've got our assign. left-hand side is an identifier A, the right-hand side is an integer 1, and then we just have, yeah, it's working. I'm happy, especially to be so tired. So we can do a few other things. We can say A is equal to true. Actually, let's do this. A is equal to false, not A, and it should be true. And then we can say A is equal to B is equal to 1, and then A is equal to A plus B. A. So what should that give us? Well, if A is equal to B is equal to 1, so they're both 1. Now A is equal to 1 plus 1, so 2, so A should be equal to 2. Oh no, it didn't. Oh wait, did I? It's like, wait, it didn't do it. It did. I forgot to change this back. That should be a 1. And I want to do this, but with P3. Because it passed, but look. A and B, those are our two values. What do we start off with? Pushing on 2 nulls, which reserves space. Integer 1. We poke it into memory location 1. That's the B. It's still in the stack. We poke it into memory location 0. It's still in the stack. It gets popped. Now we peek 0. That's the A for this A plus B. We peek 1. That's the one. We add them together. We poke it back into 0. We pop it. And now we peek it again. You say, well, Corey, what about this, how we poked it and it was there and now we pop it and then we peek it? Could that be optimized? Of course. Those are all just optimizations that we look at later. Different patterns that you look for. But the point is, right now, we have variables and we have assignment operators. Say, Corey, did that take a lot of work? Oh, yeah. It did. But we're done. It's right at 2 hours. I know it is. Or maybe it's just past. I don't know. Let's wrap this up. I'm going to... First of all, remove the dump bytecode. We're going to make clean. Now make test. While that's going on over here, I'm going to exit out of everything and get status, get diff, eyeball everything, make sure it looks right. Yeah, that should not be there. astnode.cpp should not have 2 lines there. And that's just me, but no. astnode, source astnode cpp. Source astnode.cpp. Yeah. Okay. Back to the get diff. All right, that looks good. We're compiling good. astnode assign, include astnode identifier, source astnode assign, source astnode identifier. So add variables and assignment. Yes, very happy about that. There's a lot of work. Okay, so and make docstash PDF. Yeah, that's... For episode what? What episode number are we on? I don't remember. 24. Wow. 24. Okay. That's definitely more than 24 hours of programming. We're doing about an hour and a half to 2 hours each time, so yeah. Push. Get tag-a episode .024-m episode .024. And it is there. And another one down. This one, okay, I'm not going to say that. Oh, I am tired. I am really tired. I've done 3 videos today, you know, because you got to get all the mileage you can out of your Halloween costume. And once or twice, I almost felt like I was nodding off and was like, I'm coding. How can I fall asleep? I love this stuff. But now I'm going to have trouble going to sleep because I solved the problems and it's starting to work and I'm happy about it. And yeah, so what's next? Next, I think I want to take a step back and just look and make sure that we're doing okay with our memory management. I want to look at those make copies. Do we even need that idea anymore? Maybe not. Maybe we can take those out. I want to, like I said, just double check our memory usage, and then if all that's good, we can start doing if statements. We've got variables. Either that or we need to do... No, I don't want to do prints yet. Print statements yet. I'd rather do if statements. Which then whiles are easy to include after that. And for statements. Not ranged for yet. That's a lot more work. But for statements. Yeah. Just... We're making good progress, and the language is starting to look like something that's real. And but I may need to not record as much because I can feel it in my forearms. I programmed all day today, and now all afternoon and all night. So anyway, I'm having fun though, really am. And hey, if you're watching, thank you. I hope you're having a good time, even if you watch it on double speed. But I hope you're learning something about the language design and everything. Having said all that, good night. Now, have a great day. Bye.